I'm Chitra, working as an associate professor in the Department of Computer Science and Engineering, KNN Institute of Technology and Sciences. In this video, we are dealing with the 7th experiment of Introduction to Data Science Lab, K Nearest Neighbor Classifier. The main objective of this course is to gain in-depth knowledge on statistical and machine learning techniques. Machine learning means supervised and unsupervised learning techniques. The course outcome is to discuss the principal operation of various supervised and unsupervised machine learning techniques. And in this video, we are discussing the supervised machine learning technique, K Nearest Neighbor Classifier. Moreover, we are analyzing the performance of the classification accuracy, classification precision, classification recall, as well as the area under curve. Before that, what is machine learning? Machine learning is to develop algorithms to think the computer act as a machine. So the machine learning algorithms are classified into unsupervised algorithms, supervised algorithms, as well as the reinforcement algorithms. Again, the supervised algorithms are classified into regression algorithms and the classification algorithms. Regression is mainly used for the predicting the values, and classification is to classify the given values into two different classes. There are two levels of classifications, multi-label classification and the binary classification. In the KNN classification techniques, we are discussing about the binary classification. Yes or no, true or false. Example for the binary classification is filtering the mails into a spam mail and the non-spam mails. The main unsupervised learning algorithm is the clustering algorithm. Here we are considering only the binary classification algorithm using the K nearest neighbor classification. What is supervised learning? In the supervised learning algorithms, the learning is done with the help of the labeled data. The labeled data are given. That is, for this input, this will be output. That is already given. From this data set, the classifier can be developed. The model can be developed. Means that is what called as the supervised classification. In general, supervised learning algorithm learns from the labeled set of training data. We consider that Tom and Jerry. In the Tom and Jerry, we can develop a model to separate the Tom as well as the Jerry. So one of the examples, K nearest neighbor. This is the simple, easy to implement supervised machine learning algorithm. KNN can be used both for classification and regression. In general, real world, we are using this KNN for the classification only. So this is the lazy learning algorithm. Instead of iterating some values, we are using this memorizing concept in this K nearest neighbor algorithm. So it's called as the lazy learning algorithm, and this is also a non-parametric learning algorithm. It means no assumptions are needed. The given data points are classified as it is. So in the KNN classifier, unlabeled object is divided into the target class. The KNN assumes similar things are near to each other. Here we are considering the similarity measures. The similarity between the data points are analyzed and more similar data are combined. More similar values are combined to get the final classification. Hence, the similar objects are classified into the same class. The main applications of this KNN algorithm are mainly used for finance to find the frauds and healthcare, political census, handwriting recognition, image recognition, video cam recognition, as well as the pattern recognition. These are some of the applications of KNN algorithm. And what is K in KNN algorithm? The K in the KNN algorithm implies the number of nearest neighbors. We can fix the number of nearest neighbors in the KNN algorithm. Here consider there are two neighbors, that is the red neighbor and the blue neighbor. When the new data point enter inside the pool, we should identify in which neighbor it belongs to, whether it belongs to the red neighbor or the blue neighbor. It can be decided based on the number of K values. If the number of K values is 3, in this example, our aim is to find the neighbor of the given data. How will we decide the neighbors? To decide the neighbors, we need the similarity measures. Similarity measures can be identified by using many techniques: Euclidean distance, Manhattan distance, Minkowski distance. In our example, we are using the Euclidean distance to find the similarity between the neighbors. The Euclidean distance can be calculated by using the formula root of sigma I equal to 1 to k xi minus yi the whole square. Xi is the existing point and yi is the new point. So the first one is identify the k value. K value can be chosen by the user. Next one is compute the distance between the unlabeled data to all the labeled data values. For the new value, find the Euclidean distance between the new value as well as all the existing values. Then sort the distances in the ascending order. When you sort the distances in this example, these three are the shortest distance, these two and this one is the shortest distance. These three values are, that is here, these three are the values, these three values are identified. And when we take k equal to 3, our data point belongs to majority voting is given to the red point, because two red points and only one blue point is there. So our data belongs to the red point. Consider class A is the blue color and class B is the red color. So in our example, the majority is the red color. So our point belongs to the red color. Depends upon the value of k, it may varies. It can be summarized as initially load the data, then split the data into the training data as well as the testing data. For any supervised learning classifier, we want the training data as well as the testing data. Initially, the training data, the data is divided into 70 is to 30. That is 70% of the data is used for training and develop the model, whereas 30% of the data is used for testing. What is the use for training as well as testing? Suppose you are giving some values. We know the input values and the output values. So 70% of that input values are randomly selected and that values are given for training. So during the training phase, based on the input as well as the output, the model is developed. Then we should check whether the model is developed in a good manner or not. For that, we need to perform the testing. That is the use of the testing. For the testing also, we know the values. During the prediction time, the value is predicted by the classifier. The value predicted by the classifier is compared with the already existing value. If the error is less, then the classifier is the good value. That is, the values are predicted as it is. The true values are predicted in the true manner and false values are predicted in the false manner, means that is the good classifier. So first initialize the k value with the positive integer, the odd numbers, and next split it into train and test values. After that, based on the pick the model, then model is tested, and from that we can conclude whether it is suitable for the classification or not. Again, one thing depends upon the value of k, it may differ. The accuracy can depends upon the value of k also. Selecting the value of k is a challenging one in the k means KNN classification. But in the KNN classification, suppose for the hard data set, it may work good for the value of k equal to 5. For the cancer data set, the cancer malignant can be identified correctly for the value of k equal to 7. It depends upon the data set, not only the assumption. So now we will implement by using this Python code. Data lab is used for implementing this one. This KNN algorithm can be implemented in the using the Python library functions. I'm using the data lab and social network data for analyzing this one. So as usual, import the pandas and the numpys. And next one is we are using the machine learning algorithm, supervised machine learning algorithm. So in the Python, sklearn library is suitable for the Python programming, Python machine learning algorithm. So here all the values are imported from the sklearn. Here I am using the k nearest neighbor classifier. It can be imported by using k neighbor classifier function. And I want to check the performance. The performance can be analyzed by using different matrices. In our example, the performance can be analyzed by using accuracy, precision, recall, F-score. So these matrices are imported from the sklearn library. And again, the label encoder during the classification, all the data are converted into binary classification, means it's converted into zeros and ones. All the labels are converted into zeros and one. For that purpose, I am using the label encoder. Initially, I read the value social network. The social network contains gender, age, estimated salary, and purchased. Here, the final one, this purchased is called as this target variable. This purchased is called as the target variable or the dependent variable. This depends upon all other input variables, gender, age, and estimated salary. So these values are called as the independent variables. For this independent variables, how this independent variable impact on the dependent variable, and that is classified by using the KNN classifier. First, I am extracting this dependent as well as the independent variable. So the dependent variables are extracted by using the ILO command. These three are the dependent variables: gender, age, and estimated salary as the dependent variables, whereas this purchased is the target variable. So in the purchase, it may be a no or yes. There are two categories: can purchase or not able to purchase, yes or no. Again, I use this label encoder, this function, to convert the yes or no into zeros and one. After executing this one, after transforming the function, the output may contain zeros and ones only. And in this supervised learning algorithm, training and testing plays a major role. So we should import the train and test also. In this, I am using 75% data for training and 25 data for testing. So this function is called train test split is called, and here the size of this train testing is 0.25, that is given. And by using this KNN classifier, K neighbor classifier, here I am giving the K value equal to 3. We can change the value of K, depends upon our requirement. In our experiment also, you should change the value of K as 3, 5, and 7 and compare the accuracies. Fit the values and predict the value of Y. These are the Y predicted values. Already there exists the Y test values. Compare the Y test values as well as the Y predicted values. Is it clear? X test values are given. By using that, the Y test values are already available. These are the predicted values. These predicted values are compared with the available tested values. And from that, the performance matrix, confusion matrix, accuracy, recall, precision, specificity, F1 score, and AUC. These values are calculated from the given value. So these are the performance considered. How can we measure the performance? What is the role of performance? How we measure the performance of the classifier? The performance binary classification, the performance can be analyzed by using the confusion matrix. It plays a major role. Confusion matrix will give the details about the true positive, true negatives, false positives, as well as the false negatives. First is the true positives. True positives means the values which are given as true or the positives in the data set, and that is also classified as the positives by the classifier. That is, positive values classified as positives is called as true positives. Next is the true negatives. The negative values in the data set that's classified as negatives called as the true negatives. Then false positives means these are actually negative in the data set, but it is classified. During classification, the classifier considered that false values as the positive values. That is the Negative values are predicted as positives, that is the false positives. Same manner, false negatives. These are false negatives. These are all the positive values actually, but the classifier identified this as the negative values. So these are the factors which will affect the performance. For the ideal classifier, there is no false positives and false negatives. All values are true positives and true negatives. That's not true in the case of the classification. So if the number of false positives and false negatives are less, that then only it will be a good classifier. So accuracy will give you the details. Accuracy means here is the measure of true positives and true negatives. How true values are calculated, how positives and negatives are classified in a correct manner compared to all the values. That is the accuracy. Precision means how the true values. The classifier is mainly used to, suppose, consider heart attack, heart classification, heart disease. We want to identify whether the heart disease is there or not. Similarly, malignant, whether the malignant is there or not. So positives plays a major role. The positives are identified with the help of precision. That is how the positives are predicted among all the positives. That is given by the precision. And similarly, the positive returns are given by the sensitivity and negative returns are given by the specificity. F1 score is the weighted sum of the specificity and the sensitivity. F1 score lies between the 0 to 1. If the F score is 1, that is the good classifier or the best classifier, and if it is 0, it's the worst classifier. Then the final one is area under curve. If the area under curve is maximum means, then that is the good classifier. It can be calculated by using the Python library functions. Then the inferences from the k nearest neighbor classifiers, if the number of nearest neighbors increases, then there is a possibility of increase in accuracy. Similarly, this algorithm gets significantly slower if the data set contains much amount of data. The volume of the data increases, then then it will be a slower one. The best choice of k is again a question mark. So that is a challenging one. Good k can be selected by using various heuristic technique, trial and error. Then optimization techniques can also be adopted to identify the k values. So you check all the values, all the classification accuracy with the help of different k values. Our question is, our problem definition for this lab is design a design a KNN classifier for the given data set and check the accuracy. Thank you.